Hi, this is Dr. R. Vijay Chandra, Professor in Mathematics, Department of Science and Humanities, Nanda College of Technology, Europe. So in this video, let's see about discrete random variables and continuous random variables. So before entering into the topic, let's see what is a sample space. So sample space is nothing but the range of all possible outcomes of an experiment. That is, if for example, if we toss a coin, so what you get, either you get head or tail. So the sample space is nothing but S is equal to H comma T. That is, either you get H or you get T, right? That is tail. So this is called as a sample space. That is, I repeat, the range of all possible outcomes of an experiment. Here experiment is a tossing a coin. So the possible outcomes are H comma T. So this is called as sample space. Now we see the definition of random variable. So what is a random variable? A random variable is a function which can take on any value from the sample space. That is, it takes the value from the sample space and having range of some set of real numbers is known as the random variable. So the random variable is nothing but which is a function which takes the values from the sample space, right? So here there are two types of random variables, so which is classified as discrete random variable and continuous random variable. So let's see one by one. So what is a discrete random variable? So discrete random variable is nothing but a random variable which takes on only finite number of values. That is, these are the random variables which can take only finite number of values in a finite observation interval. So which takes only finite values in the finite observation interval. So in the finite interval, it takes only finite number of finite values. So we can say that it has distinct values that can be counted. So for example, let x represent the sum of the numbers on the two dice when two dice are thrown. That is, we are taking two dice and we toss the two dice simultaneously. So here let x represent the sum of the numbers on the two dice, right? So in this case, the random variable x takes the values 2, 3, 4, 5, 7, 8, 9, 10, 11, 12. That is, if you toss two coins simultaneously means in the first coin you may get one. For example, if you get one, second coin if you get 2 means the sum of the numbers is 3. So likewise you get 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. That is, this is the random variable capital X. That is written as capital X equal to set of all 2, 3 up to 12, right? So X is the discrete random variable. Why we call this X is a discrete random variable? Because we have only finite values. That is from 2 to 12. Only we are having finite values. That is why it is called as discrete random variable. So hope you understand that. So next we see continuous random variable. A random variable that takes on infinite number of values is known as a continuous random variable. So in the case of discrete random variable, we deal with the only finite values. Here we have infinite number of values. It is dealing with infinite number of values. It is defined on, it takes on infinite number of values. So many experiment can produce infinite number of outputs in a finite time of observation. So some of the experiments may give finite values, and some of the experiments we may be considered it may give infinite number of values. So in that case we use continuous random variables, or in other words is defined as a random variable x is said to be continuous if it can take all possible values between certain limits. So for example, a random variable that measures time taken in completing a job is continuous random variable. So in this example, that is x takes the time, x is nothing but that measures the time taken in completing a job. That means a person A completes a job within half an hour, means person B completes the job 20 minutes. So some other person completes the job within 45 minutes. So this may happen. So in that case you may get infinite number of values in that collection, right? So in that case this is an example for continuous random variable. So another example, temperature recorded in a city during the particular interval. So during the particular interval